Kilian, you got your camera on, man. You might as well go.
All right. Yeah, let me start sharing my screen. All right. So you should be seeing me. You should be seeing my slides. Tell me if something isn't working. I guess questions at the end, or
Yep.
however you want to handle it. I'm also happy if someone wants to jump out if something isn't clear. Anyway, I'll be talking about code completion to autonomous software engineering agents. In particular, we're going to cover benchmarks. That's mostly SWE-bench, which is used to evaluate agents on that are solving real-life GitHub issues. And SWE-agent is our agent that's doing that. So I'll talk a little bit about agent basics. How can you build an agent like that? Then I go a little bit more into detail of how SWE-agent is built, both from kind of like a software engineering architecture perspective, and also maybe a little bit of the tips and tricks that you're using to get good performance. And then there's going to be a small summary. So SWE-bench and SWE-agent, it's quite a lot of people who can see all down here. All right, let me get into it. So first of all, let's talk about benchmarks. So there's like a lot of hype about agents, and to figure out if you really should pay $20,000 a month for like this rumored OpenAI agent, we better have some way of evaluating that. So traditionally, when AI was first used for coding, what people would do is something like, I'm gonna call it the human eval style. So you would, for example, start writing some code, and you have some signature, and you have some doc string describing what the function should do, and then you ask a language model to fill in the code for you. And then you can test it with unit tests to evaluate if it really does what it's supposed to do. And that's a great benchmark for many, many reasons and applications. It's a great benchmark for evaluating code generation and for something like autocomplete. However, when we now look at kind of most of our like software engineering daily life, it looks a little bit different. So usually we already have like a really large code base, and at some point someone has a bug report. So they try something, it doesn't work, and maybe you're first like, well, I don't know, it worked on my machine. But then they double down on it, so you're like, all right, okay, that looks like something I need to look into. And so you spend quite some time actually reading code. Then you try to reproduce the issue, try to make some edits to the code, try to solve the thing, and then hopefully you're going to add some regression test. And then you submit a pull request, and you're done. Except that in reality, it doesn't look as smoothly as this, but more like something like this. It's like highly iterative. You change a lot of stuff, see what happens. Hopefully, in the end, you verify it all, and then you're really done. So SWE-bench essentially is a benchmark that tries to capture this process and evaluate agents on the same tasks. And this is done by taking real-life GitHub issues. So like the full set has maybe like 2,000 of them. You take the issue, you take the entire code base, and you ask whatever system wants to solve it, to create a real pull request. That can be done with like rags or agents or whatever you want. And then in the end, we validate this generated pull request with unit tests, and we can go into details about how this is being done. I just want to highlight how challenging this is, because this is an extreme length of context, because those code bases might be hundreds of thousands of lines. It's very reasoning heavy, right? Because you have to understand what's happening in the code. You have to understand what the problem is. You have to make really good edits. And there's enormous action space for an agent. Even though, when we later look at tools, it might look relatively simple. It might look like, oh, well, there's like just 3 tools. But one of them is actually like an execute bash command tool, right? So you can execute arbitrary commands, and even things like, like searching or editing. Yes, it's a simple, like it's one tool, but like the space of, all that possible edits you can do is still very, very large. So all of these things make it like a really good and very challenging benchmark. Now, I said it's very challenging, but actually, like in the last year, there has been like tremendous progress. So let's go to this step by step. There's 2 colors. There's gray and there's orange. Gray means last year. Orange means last month. And there's like 3 groups of these bars, because SWE-bench, and that's like a little bit more technical. It has three different subsets. So full on the right is basically just taking all 2,000 issues. And then there's two subsets that are slightly simpler and have like different filtering. And we can go into the weeds about, what each of these means and, what you should evaluate on and so on, if you want. But, I think the main message here is very clear. We went from like, let's look at light, we went from like 20% to almost 50% within a year. So agents are coming and models are getting better and better. So this is with SWE-agent. It's two different models. Like, last year we were evaluating on GPT-4o. Now it's Claude 3.7, and it's really the language models that are responsible for this huge gain that we are seeing here. So I tried to pick some things that are easy to compare. That's why it's all SWE-agent. It's generally the same agent scaffolding, but there are different tools in use, like the tools that we give to the language model to use, and the prompts are slightly different. But still, I think it's fair to say that it's mostly the language model that's responsible for this huge gain. All right, so let's jump to agent basics. Like the first attempt to create an agent would be to just put the language model in the terminal. You give it a question, you have the agent proposer dash command, you execute it, you return it, and then you just loop. And you can do it, but bash commands are hard. And humans also don't really like to use them, for editing files, which is why VS Code exists and Vim exists and Emacs exists and all of these things. So the central claim from the SWE-agent paper last year was that just like humans need specific tools, so do you need to create like a specific agent-computer interface for your language model to interface with your computer. And that's what we call the ACI. So, it looks pretty simple, like you have a language model agent or just a language model. You provide it with some language model friendly commands that interface with your computer, and you send back language model friendly environment feedback. So the next couple of slides, I'm going to step through like a couple of these things, like tools and generally how to build an agent. So starting with tools, so this is a result from April 24, and I'm going to talk about how this changes. But what we did was we basically compared this shell-only, put the language model in the bash terminal way of doing things versus like a specific editing command that we crafted. And the resolution rate went from 10% to 18%, so almost double. And if you look at shell-only editing, it's quite hard. Like the model would do like something like cat, but then it might be a really really long file, and like in order to edit, it would use like these very long set commands replacing stuff and so on. Versus our edit thing was something like we would show the language model like a page of output at a time, and it could basically do like line number based replacement, something like that. So that was 1 year ago. I think a lot of things have changed since then. So the most popular tool I think for editing now is like more search and replace based, though it kind of depends. But in some way you could say we're like moving a little bit closer to the set thing again. Even though I think Anthropic 3.7, what they tried recently was more like a rewrite thing, which is actually closer to what we did with SWE-agent again. So there's like a little bit of back and forth here. What we did last year, like back then, GPT-4o and so on, they would still make a lot of mistakes when editing files, like even syntax mistakes. So we linted the files, the edits, and basically blocked things that are obviously bad. That's less needed now. I wouldn't do it unless you're doing with an open source model. It might still be beneficial. But I think that the single important thing here, if you're writing a software engineering agent, the edit function is the most important part of your tools to optimize. You really should get that one right. But generally, language models much better at using tools, also many tools. Like last year, we were seeing a lot of confusion if you give the agent too many tools. So we were really trying to make it as simple as possible. You can get away with more complex tools now. Second thing, prompts. So on the right, you see kind of how an agent trajectory looked. So this is from last year. And you start with like a system prompt and then an instance prompt that describes the problem you want to solve. So you explain the mission, the general strategy, and you give some tips. Now, this year, I think you can be actually very sure, like with Claude 3.5 plus, it's like 1 or 2 paragraphs. last year, you would give very specific tips to work against, all the problems that would appear. You also don't need to explain tools anymore if you're using function calling. So generally much simpler now. The other thing, demonstrations. Demonstration means you take a whole trajectory of how an agent or how someone solved a problem, and you dump it into the context, for the model to mimic. No longer needed, and it can actually be bad because it can lock your agent into specific patterns of trying to approach a problem, which is bad if you have like a high variance among your tasks. It can also be good if all of your tasks are exactly the same and you know exactly how it's to be solved. I'd say it's useful if your language model makes a lot of formatting mistakes or messes up the tool use, or it doesn't do like React or chain of thought out of the box. So I guess that's for weaker models. So then it can still be beneficial. We don't use it with Claude anymore. And I guess that's what you typically I guess call like the agent scaffolding. It's like more like how do we structure the flow of how do we iterate on the inputs and outputs. So one thing we did a lot with SWE-agent last year was history processing. So you have your history of all the actions and the outputs. And previously, to conserve context windows, we were keeping only the last 5 observations. So you see that here on the right, you have some collapsed responses that we stripped out. One of the problems breaks caching, which now all models have. So it makes it really expensive. And also new models can deal very well with long context. So we don't use it anymore. I mean, we still process the history a little bit, but don't discard stuff. It's going to break your caching, makes it expensive. Second thing, your flow needs to maybe recreate a language model if it doesn't give you a tool call or something. You need to handle environment stuff that goes wrong, and you need to stop before you spend too much money. So those are kind of like the basic ingredients. Then one more technique that got quite popular for benchmark submissions is reviewing and retrying. So basically what you observe is that if you try the same problem multiple times, you just run your agents multiple times on it, the probability that one of them is resolved, which is what we call path at k, goes up and can go quite up quite a bit. That's somewhat related to the variance of the success of a particular instance. I would say bottom line is less payoff, the better the model gets. So it's going to do less for Claude 3.7 than for Claude 3.5. And also picking the best solution isn't really easy, especially if your solutions are generally good. It's definitely not cost efficient. So if you're looking at real world use cases, you probably don't want to do it, because I'd say you get like 5 to 10% points for maybe 5 to 10 times the cost. Okay, that's like kind of, there's not really real numbers, but just to give you like a picture, I think it places you like in the same, like in the right ballpark. I think doing supervised fine-tuning of some classification review models might help a lot here. So maybe we're going to see this getting a lot better in the future. But right now, if you want to do kind of a real-world thing, it's probably not so relevant for you. If you want to be on the benchmark, it's probably very relevant for you. How to iterate. So I spent like 1 or 2 months recently on getting SWE-agent back on the leaderboard. One thing I want to say is be very mindful of statistics and interpretations. There's 3 examples here on the slides. I think I'm running slightly behind on the time, so I'm just going to skip them. But what I want to say is, when you do experiments, they should be meaningful and they should have enough instances to have the right resolution rate. So if you do 50 instances and you solve half of them, you're still going to look at like 25% confidence interval for your solution rate. So, I would say, and there's kind of like the tips here, if you're on experiments, make sure they are really meaningful to what you're doing. The other general tip is, I would say, simple and stable just generalizes much better than like a very complex and brittle setup. So language models are going to change, and maybe your tasks are going to change. The more complex your system is, the harder time you're going to have to adapt. And for example, one thing we are seeing is that as language models get better and better, we can actually reduce scaffolding. We can reduce a lot of things we did to, I don't know, catch GPT 4.0 or something to make mistakes. Because Claude, for example, doesn't need all of these things, and in fact, sometimes does better if you don't do it. The other thing is, I would recommend to just read lots and lots of trajectories to figure out, what's really going wrong, and not only focus on like statistical figures of merit. Right. So let's talk about SWE-agent. So that's now chapter 3. So we started working on this shortly after the SWE-bench release. It's open source since almost a year now, so it's one of the oldest, I would say, software engineering agents that was scoring well on SWE-bench. And we recently released SWE-agent 1.0, which was a major update. We almost completely rewrote it. It's very nice code now. It's highly parallelizable. You can execute actions on the cloud. And you can actually evaluate on all of SWE-bench Lite, which is like 300 instances, in 30 minutes. And that's without cloud. That's just running on like a MacBook or something like that. I think you should better run it on a Linux machine if you're doing benchmarking. But anyway, very fast, very configurable. I think there's like more than 100 options of things you can tweak. But it's also like a very straightforward, no fluff system. So it's very easy to hack. It's made for research and experimentation. And we're doing pretty well on the SWE-bench leaderboards, which are currently being updated because obviously a lot of things shifted with Claude 3.7. I want to do this live, but I think in interest of time, this is how it looks when you run on a GitHub issue. You're gonna see, like the actions coming out and, like the results of these actions. And in the end, you can get a pull request if you want. And this, again, I'm going to skip over this. If you run on a larger batch of issues, you can parallelize it. This is just on like a standard kind of maybe MacBook equivalent machine. You can run easily 30 to 50 instances in parallel. Oops, I forgot to add all the animations to this page. Quick look at the implementation. So let's start up here. I hope you can see my mouse pointer. You call SWE-agent run or run batch. It's basically creating two objects. One is an environment object that's going to hold whatever we execute actions in. And the other thing is the agent object, which is your agent. The agent is parameterized mostly by one config file, or I think there's only one config file that includes everything. And it basically iterates on a forward method that takes all the previous history, puts it through your history processor. We briefly mentioned that, gives this to a model, gets the action that the model proposes, and it hands it to this environment. And here I want to briefly plug one of our packages that made a lot of the improvements with SWE-agent possible. It's called SWE-rex for remote execution. And this is basically what we use to execute sandboxed actions. So it's like a very tiny package, but what it does is it spins up Docker containers that have your environment set up in. It starts a little bit like a small server in it. That server is going to talk to a bash session, and basically you can now take commands, put them in the bash session, get the environment feedback out, and also takes care of installing our tools and environment and so on. So, it's like E2B if you're familiar with that, but it's a very small package that's easy to hack and has some advantage. Like it's very tailored to what we're doing, so it's very specific purpose. Other than maybe E2B. So I think if you're building an agent and you don't want to use SWE-agent and you want to start completely from scratch, maybe take a look at SWE-rex and see if that solves some of your problems. Because like dealing with these environments and dealing with these running bash sessions, it's pretty nasty, to be honest. So this is also one of the reasons why SWE-agent is now a lot cleaner in the code, because a lot of this dirty work is handled by SWE-rex. That brings me to my summary. I think I mostly stay within time. SWE-bench, very challenging benchmark, long context, high reasoning, large action space, so very good for evaluating agentic capabilities of the current language models. If you want to compete on there, I would say keep it simple, read lots of trajectories, run meaningful experiments. Of course, you can also go completely crazy and so on, and it's going to be very interesting what your results are. But if you want to do it for a long time, I think simplicity and simplicity paired with good engineering might get you slightly further. Review and retry, that was one of the specific things I mentioned. Probably needed if you want to be on the top of the benchmark right now. But it's not very realistic, as in like it's very expensive for just a few percent points that you get on top. SWE-agent, we're fully open source, so please check us out, and we're happy for people contributing, actually. Very highly configurable, parallelizable, easy to hack. So it's really made for this research experimentation thing. Also means that, of course, maybe slightly less batteries included if you just want to use it as a tool. But that's I think like a basic trade-off. And SWE-rex if you just want to build your own agent and care about sandbox code execution. Maybe check it out. I think that's all I had to say. I don't know how we proceed. Excellent. If there's direct questions, happy to take them, or we move on.
Yeah, I am happy to have anybody come off mute that wants to come off mute. I've got questions always, but I want to hear from others too. Or if you prefer, you can just drop them in the chat if you're in a place where you can't talk or you don't want to talk. The things that are top of mind for me while people are starting to think about their questions is, one, how often are you updating SWE-bench? And
right,
then, yeah, go ahead.
I'd say it's roughly like once a month. It's mostly John from Stanford who's managing that. Currently, there's a lot of submissions with 3.7, so it's going to take a while. So like every 2 weeks, once a month, something like that. That's for just evaluating, making sure that nobody. Basically, there's some rules in place to make sure that you really have a real contribution to the leaderboard, and that takes time because it means a human has to check.
Nice. But you're also updating the benchmarks themselves, or you're just updating like the leaderboard?
The benchmarks are fixed so far. So these 3 splits are fixed. There is a new benchmark called SWE-bench multimodal, which is JavaScript rather than Python. And it has images that are required to solve the things. That's also very challenging. Nice. And there's a new instances. We are working on more updates. But it's also, I think it's nice to have some amount of consistency in seeing how models scale on a fixed benchmark.
Yeah, it makes sense. The other question I had, unless anybody else has a question, or feel free to shut me up by clicking the raise hand button and I'll stop talking. But one of the main questions that is top of mind for me is, you mentioned sometimes you see that like less is more, and almost like as you take away scaffolding, it performs better. Have you seen I'm specifically thinking of reasoning models.
Yeah.
If they perform better by just like letting them reason it out?
That's what OpenAI says, right? Like when you read through their O1 instructions. So we don't use O1 as an agent. I think someone from Weights and Biases used O1 like as a main agent driver, but it's not open source, unfortunately. Sure. Yeah, I think it's true. Like, for example, what we do when we do multiple attempts currently, my very silly solution is we take the 5 patches from the 5 attempts, we just pass it to O1, and we literally basically say like, hey, which of those is the best? Like, we don't say like, here's the 15 things you should check. We just say like, what is better? And it works very well. I haven't really, with like Claude, I haven't seen that like having a longer prompt necessarily hurts it if it's just tips. I think the one thing you should be careful about, and that's the same with the demonstrations, is if you're forcing it into a path that's maybe not optimal, or that's only optimal for a subset of your tasks, that might hurt your performance. And I'm pretty sure that's the same for O1. It's just like if you have a predefined notion of how a problem should be solved, but it's not informed by the entire set of instances, but only by a few, then you just have like this generalization problem.
Excellent, dude. Well, this is sweet, and I appreciate you giving this talk.